This video will include a brief description of what a significant figure is, how we collect and work with data, and how we round and how we perform operations. So first off, we have to talk about what we mean by significant figure. And this is something that is only important when we have a measured quantity. And so by measured, I mean something that we have to use a instrument to collect, so a ruler or a scale or anything like that. If it is a number that you have counted, that is not a measured quantity because you were able to discretely count the number of objects. So for example, a dozen eggs, that isn't a measured quantity because we can look at the carton of eggs and count that there's 12 and there's no uncertainty with that number. But if you were to take the mass of those eggs and put them on a balance, there might be some uncertainty in the instrument. And so significant figures are all the digits that we know with certainty and the first uncertain one. And so that's where that comes from. So in this example here, we have a ruler. And it's actually not marked what the units are on it, but it should be in centimeters. So these big black lines are centimeter marks, and then these marks here are millimeter marks. And so what you would do to measure the length of this object here is you know that it's 1, 1.1, 1.2, 1.3, and then you have to estimate the last one. So we know it's at least 1.3 because it's past the 1.3 hash mark here, but it is not yet quite to the 1.4 hash mark. And it looks like it's a little bit um, just over halfway toward the 1.4. So we could record this as 1.36 centimeters or 1.37 centimeters because that last digit is where the uncertainty is. And it's okay, we know the 1.3 for sure, but then this last digit is estimated, and so that's where the uncertainty is in our measurement. So how do we know if a digit is significant if we didn't measure it ourselves and we're just looking at some data? So there are two two types of digits that are always significant. And the first are non-zero digits. So in this case here, we have 4 non-zero digits, and so we would know all of these to certainty. 1, 3, 5, 7. So there's 4 significant digits in this number right here. If you have a 0 and it is between non-zero digits, then those are also significant. So in this case, we have a 4 and a 5, so that 0 becomes significant as well. And so this would be 3 sig figs. Never significant are leading zeros. So in this case, we have these zeros here. They are merely placeholders to tell us where the decimal place is. And so a good trick for is a zero significant, if I could rewrite this in scientific notation so that the zeros weren't there, then they're not significant. And so I could actually write this as, I could move my decimal place. I see that there's 4. So I could write this as 4.58 times 10 to the negative 4th milliliters. There's only 3 significant digits in this number. I could also use a prefix in the metric system in order to change this. So I could write this as 458 nanoliters because a nano is 10 to the 9th of a liter. And so, and milliliter is a 10 to the third. So there's 1,000 milliliters in a liter, and there are a trillion nanoliters in a liter. And so if I were to move the decimal place 6 spots to the right, and then it's milliliters, then I would have 458 nanoliters. So because I can do this, that's a hint that these are not significant, because the only purpose of those zeros is to show me where the decimal place is. I don't know anything about what should be in that place. Now we have a trailing zero, and it depends. So trailing zeros are only significant if the number has a decimal point. So in this case right here, these are not significant because there's no decimal point. And so we only know to the hundredths place. So we know this measurement accurate to the 100 meters, so 1,500 meters. So then the uncertainty is in this digit right here. And so this would have 2 sig figs. But if we know that we calculated it all the way to the hundredths place, and we're using zeros to show that it is exactly 1,500 meters, then we count all of the digits. So we have 1, 2, 3, 4, 5, 6. 6 sig figs. And so when you're looking at a number, you want to think, where are the non-zeros? Identify those first. And then you look to see if there's anything between those non-zeros. Those are all significant, and then you have to examine the trailing zeros and decide if they're significant or not. So when we do our lab, for example, you will often have zeros after a decimal point because our analytical balances report, I think it's 3 digits after the decimal point. And so if your balance reading includes zeros, you definitely need to record them because they do count, they matter. And so you need to record every digit that you can off of your instrument. Same for the graduated cylinder. If you get exactly 50.0 milliliters of water in there, you would need to record 50.0, just like this is recorded here. So if we want to do some practice, you may want to pause this and try it on your own first. But as a reminder, we've got our leading zeros here, we've got our buried zeros here, and our trailing zeros here. And so if we look here, we see that we have these are non-zeros. And then the zero here is in between 2 significant digits, so that's 4. Here, we've got leading zeros, which are never significant. And we've got 2, 8, 3, and then that 0 is in between these two here, so that's 4 as well. And then 300, there's no decimal point, so those are not significant, so it's just 1. So you might be wondering how to round. Well, to round a number, you have to know how many sig figs the number should have. So let's say in the lab you're calculating density, and this is your calculated value that you get. But we know that our instruments weren't all accurate to this decimal place here. So we need to round this to 3 sig figs. And so what you do is you look at the number directly to the right. And so we want 3. And so that means that these are 3 sig figs. So then that means that this 5 here is the number we're going to look at. And we see that this number, if it's 0 to 4, we don't change this digit here. But if it's 5 to 9, then we do change that by 1. So if we round 201.587 to 3 sig figs, we get 202. We will often do some math with our numbers, and the rule generally is that you don't want to round until the end. You pay attention to the math that you have done, and then you can round at the end. So for this number here, we look at our addition or subtraction, and what you do is you look at the number of decimal places. And so here, this is set up to show you that this number here stops at the 10th place. And so we're going to round at the end. And so we don't want to round at the beginning, because if we round at the beginning, that could potentially affect our answer. So we calculate it and then we round at the end. And so if we know that we're going to limit here, we look at this. This is an 8, so we know we have to round up. So our answer becomes 1,459.1. If you're multiplying or dividing, you limit the significant figures in the answer to the number with the lowest count. So in this example, this has 4 sig figs, 1, 2, 3, 4. And this one here has 5, because this 0 is between two regular numbers. So we have our answer here. So we calculate it out first, and then we round, and we get 4,094, because we look at this digit here, and it's a 1, so we do not change that 4, and we just leave it as 4,094. So here is some practice, and if you would like, you can pause here and try it on your own. So I'm going to show the whole answer as I put it in my calculator, and then I'll show you how to round it. So here we have 0.0420 times 55.98, and my calculator says 2.35116. Okay, so I need to know how to round this. So I look here, and I see I've got 4 sig figs in this number. And in this number here, there's a decimal point, but this is a leading 0, so it doesn't count. But this is a trailing 0 after a decimal point, so it does count. So I've got 3 sig figs in this number. So then I need to round my final answer to 3 sig figs. And so I do that by looking at this number here. I see that it is a 1. So it is between 0 and 4. So 2.35 is my answer. And now for this one here, I see that it's the 10th place. And so if I put it into my calculator or just add it up, this is the answer I get. And I want to, I need to stop at the 10th place, so that 9 will be my last digit. So I look here, and we see that it is a 3, so I don't need to increase that digit at all. So it is 958.9. And then 30.2 divided by 23. When I put that in my calculator, I get a long number, lots of digits, so I just typed in the first few. And I see that it is, this one only has 2 sig figs, so I need to have only 2 sig figs in my answer. So this is the one I'm gonna keep these 2. This is my uncertainty digit, and it's a 1, so I round this to 1.3.